Hi, I'm Cassie, and I'm going to walk you through question 39 of the AAMC's official physics question pack. So this is the last question associated with passage 6. And actually, if you look at the content, it's really similar to what question 36 is asking earlier in the passage. Question 36 was asking where the point of maximum potential energy is. It wanted to know if that point of maximum potential energy was at position B, when the sea of electrons is directly on top of our positive ions, or was that position A or C, when our sea of electrons gets displaced either to the left or to the right of its equilibrium position on top of those positive ions. And remember back in the explanation for question 36, we talked about the fact that that max potential energy occurs at position A and C when our electron C gets displaced. And that's because of that displacement. When our electron C is displaced, work is done to displace it. Remember, work is force times displacement. So when the electron C moves, it's moving against a force, our charge gradient, and it's getting displaced. So work is being done, and that work needs to be stored somewhere. And that's what potential energy is. It's just stored energy. So now if we think about this question, question 39, when the electrons move from that position A, which is where they were already displaced, to position B, well, we said that at position A, they've got a lot of potential energy. And then as they move back to their equilibrium position, they're going to be having less and less potential energy, and they're going to be gaining more and more kinetic energy. And that's because, remember, kinetic energy is just, our equation is 1/2 mass times velocity squared. So it's got velocity in it. Kinetic energy is the energy associated with movement. So as soon as those electrons start moving back to their equilibrium position, they're getting some velocity, they're getting some movement, so their kinetic energy is increasing. Whereas again, they're going back to their equilibrium position, so their potential energy, their displacement, is decreasing. So in other words, our answer here is going to be answer choice B for me, that potential energy is transformed into kinetic energy. But let's talk about why the other answer choices are wrong. Well, answer choice A says that kinetic energy is transformed into potential energy. That's the opposite of what we just said. At first, our electrons, they had already been displaced and they weren't moving kinetic energy. So it's, in other words, the answer choice A is the opposite of what we want. Answer choice C, power is dissipated as heat. Well, remember, our equation for electrical power is just going to be power equals current times voltage. And we can use Ohm's law, which is voltage equals current times resistance, plug into that original power equation, and then we're going to get that our electrical power is equal to our current squared times resistance. In other words, for power being dissipated as heat to be a relevant factor in this problem, we have to have some sort of source of real resistance here. Now, in the case of plasma oscillations, we don't really have a medium that's providing a lot of resistance. So that's why the answer choice is going to be wrong. And then the last answer choice, turbulence brings the electron C to rest. That's just one of those answer choices that's classic, like beyond the scope of the MCAT. You don't really need to know anything about turbulence for the MCAT. If you did need to know something, it would be told to you in the passage. And in this case, there's nothing about turbulence in the passage, so I wouldn't even worry about that answer choice. It also doesn't make a lot of sense, right? If you think about turbulence, like the kind of turbulence you experience even when you're on a plane, that doesn't bring things to rest, right? That sort of shakes things up. So D would be the first answer choice I would have crossed off. So I hope this helps. Make sure to go back and review question 36 if you haven't already, to really consolidate some of these concepts. If you can't tell already from doing this many questions of the physics question pack, the AAMC really wants you to understand the difference between potential and kinetic energy, and how specifically it applies for charged particles and their movement. Oftentimes their movement between capacitor plates, as we already saw. If this helps, give this video a like, and please follow my channel for more content like this.